Yeah, actually, I got up so early this morning, and then actually one of my acquaintance I told you yesterday, and then who just died last Sunday, and then she just left a lot of projects, so I have to proceed with her like project. So I just had some Zoom meeting with the other acquaintances. So that's why I just delayed this about the lecture. So yeah, I'm sorry to make it to a little bit late. So it is okay.
Yeah, sure. It's fine. I
Okay.
understand. So she had a lot of appointments that you had to take over.
Yeah, yes, exactly. And then it is quite like a big project with Korea, like some like Southern Korea part of like architecture project, and then also there's a many university professors combined it. So we have some like discussed about how to solve this problem because of she just suddenly died. So actually, I'm a professor as well, but my field is psychology and psychoanalyst and educator. So, but the architecture field is different field, so it is quite difficult. But her like project is a little bit like related to the statistics. So
Mm,
if I can just can involve into the project, then I want to give some help to their project, but I have to be very honest, I think so. Yeah,
oh,
and
those
I
are big projects.
yeah, and I sent some like image files to per today's class, so teachers check.
Yeah, I opened it.
Okay, so yesterday we've done about statistics, and then there are some terminology about mean, median, and mode. So you already know the meaning of this terminology, and then another one we I just send the like this one. Let me see. I will share. So there's another. Okay. So this is the graph. So yesterday we just saw this graph, three different graphs, A, B, C, and so A is mathematical distribution and B is positively skewed distribution and C is negatively skewed distribution. So these are the like different and like the vertical it means frequency. So today I will continue to explain about what it means and more specifically, okay?
Okay.
So let's continue this one. Like some, let me see. Yeah. So yesterday we saw I just told you and measures of variability
Mm,
are another type of descriptive and statistical measures. Again, you may be familiar with some of these measures, such as the range, variance, and standard deviation. So, measures of variability attempt to depict the diversity of the distribution. The range is the distance between the highest and the lowest score in a distribution. Do you understand?
Mm.
Okay. And the variance and standard deviation are closely related. So standard deviation is simply the square root of the variance. So these both measures is essentially relate the average distance of any score in the distribution from the mean. Do you understand?
I see.
Okay. The higher variance and standard deviation and the more spread out the distribution. So this is what it means. Do you understand? Okay. And sometimes being able to compare scores from different distribution is important. In order to do so, you can convert scores from the different distribution into measures called z-scores. So this is a little bit difficult meaning. Z-scores measure the distance of a score from the mean in unit of standard deviation. Scores below the mean has negative z-score, while scores above the mean have positive z-score. For example, if Clara scores a 72 on a test with a mean of 80, then a standard deviation of 8. Clara's z-score would be -1. If Maria scored an 84 on that same test, her z-score would be plus 0.5. Do you understand this example? Do you understand?
So the -1 or -1, this
Mm-hmm.
is the square root of 8, is it?
Yes, right,
Mm.
exactly. Okay. And then often in psychology, you will see reference to the normal curve. So normal curve is a theoretical bell-shaped curve for which the area under the curve lying between any two z-scores has been predetermined. Predetermined. For example, approximately 68% of scores in a normal distribution fall within one standard deviation of the mean. Approximately 95% of scores fall within two standard deviations of the mean. And almost 99% of scores fall within three standard deviations of the mean. Knowing that the normal curve is symmetrical and knowing the three numbers given above will allow you to calculate the approximate percentage of scores falling between any given z-scores. For example, approximately 75.5% of scores fall between the z-score of 0 and +2. So Later, we can see the picture 2.2, then I will explain more about this sentence, okay?
Okay.
Okay. While Z-score measures the distance of a score away from the mean, percentiles indicate the distance of a score from zero. Someone who scores in the 90th percentile on a test has scored better than 90% of the people who took the test. Do you understand this means?
I see.
Okay. Similarly, someone who scores at the 38th percentile scored better than only 38% of the people who took the test. A clear relationship exists between percentiles and z-scores when dealing with the normal curve. Someone who scores at the 5th percentile has a z-score of 0, and someone who scores at the 98th percentile has an approximate z-score of +2. So it's a little bit like difficult meaning, but later, like with the graph, I will explain more about z-score and correlation. Let's see this one. A correlation measures the relationship between two variables. Maybe you will learn about the meaning of the variables, right?
Right.
Okay. So, as explained earlier, correlations can be either positive or negative. So, if two things are positively correlated, the presence of one thing predicts the presence of the other. But a negative correlation means that the presence of one thing predicts the absence of the other. Do you understand?
Right.
Okay. So when no relationship exists between two things, two variables, no correlation exists. So we say correlation is 0. As an example, one would suspect that a positive correlation exists between studying and earning good grades. Then it would be positive correlation because more and more studying, then they can get more and more good grades. But in contrast, one would suspect that, okay, let me see, negative correlation might occur between cutting classes, like I mean absence, and earning good grades. So it is negative correlation. So finally, it is likely that there's no correlation between the number of stuffed animal one owns and owning good grades. Do you understand these examples?
Yeah, the example is on point.
Okay, so let's look at the graph with this one. So this is the normal distribution. So we've learned the z-score, the meaning of z-score. So there are the three meaning: mean, median, mode. So This is normal distribution. And like Pearl, it is just converted into the Z-score. It is just 0. And this score, this part, like plus positive 34.13% is plus 1. Then it is just a plus 1 score, plus 1 Z-score. And next one is plus 2. And next 3 is plus 3. And the opposite is minus 1, minus 2, minus 3, Z-score. And look at here, this is Z-score, and next one is percentile. So it is almost 50s. And then 48.13%. And this is 99.87%. So just Z-score 3 means almost very high percentage. It is only very rare. Do you understand? Yeah. So Z-score 1, 2, plus 1, plus 2, plus 3, or minus 1, minus 2, minus 3, it means there are many like different like percentages. So, and also this is frequency. So let's look at more about more examples. So, for example, correlation may be either strong or weak. The strength of a correlation can be computed by a statistic called the correlation coefficient. So it is called correlation coefficient. So correlation coefficients range from -1 and +1, where -1 is a perfect negative correlation and +1 is a perfect positive correlation. And both -1 and +1 denote equally strong correlation. It means it is really, really related, okay? So, as previous like example, studying hard and earning good grades, or absent cutting classes and earning good grades. They're very related. So they're almost like plus and minus one, like correlation.
Oh,
Yeah.
okay.
So, and also the number of 0 denotes that the weakest possible correlation. For example, the number of snuffed animals, owing animals who owns, and earning good grades. There's no relation, okay? Then no correlation, which means that knowing something about one variable tells you nothing about the other. Do you understand my example, what it means?
Yeah, so there's no relationship at all if it's 0.
Okay. So, a correlation may be crafted using a scatter plot. A scatter plot graphs pairs of values, one on the y-axis, So later I will show the graph and then I will explain more about the sentence. And one on the x-axis. For example, the number of hours a group of people study per week could be plotted on the x-axis, while their GPAs, good grades, could be plotted on the y-axis. Then there are more and more study time, then they are getting more and more like good grades. The result would be a series of points called a scatter plot. The closer the point come to falling on a straight line, the stronger the correlation. The closer, the stronger. The line of best fit, or regression line, is the line drawn through the scatter plot to minimize the distance of all the points from the line. When the line slopes upward from left to right, it indicates a positive correlation. A downward slope evidences a negative correlation. The scatter plot depicting the data set given in table 2.1 is graphed in figure 2.3. And let's look at here. On the right side, there is a tip. So students they can easily have some mistake, or there is some tendency often believe strong correlation correspond to positive numbers. But do not forget that minus 0.292 is exactly as strong a correlation as plus 0.292. So whether it is plus positive or negative, the strong is almost the same. Yeah.
I see.
Okay, let's look at later. Okay, this is a table. And here, so the relationship, the title is the relationship between our studies and GPA. Okay, Teresa studies 15 hours and she got 3.8. And like this, and Lau, Toad, Lucy, and Rome, Pam, Letitia, Craig, Megan studied like this, and then they got GPA score like this. So maybe you might understand this table, right?
Right.
And then they make a graph like this. Here, this is figure 2.3, and this is scatter plot showing the correlation between our studies and GPA score. So this is the time, how many study time, and this is GPA score. So like this, it is almost like this. So this is the line of best fit. So let's look at tip. As discussed previously, a correlation, no matter how strong, does not indicate a causal relationship. Do you understand what it means?
So it's just closer to each other.
Okay, okay, it is good, very good. And next, really, I will explain about inferential statistics. So this is also very popular, but a little bit more typical, more complicated. So whereas descriptive statistics provide a way of summarize information about the sample studied by abnormal about the sample studied, the purpose of inferential statistics is to determine whether or not findings can be applied to the larger population from which the sample was selected. Remember that one of the primary goals in selecting a sample is that the sample represent the population from which it was picked. If a sample does not represent a larger population, one cannot infer anything about the larger population from the sample. Do you understand up to now?
Yeah, inferential statistics is like for larger population.
Okay, good. Guaranteeing that a sample is representative of a population is impossible. So, the extent to which the sample differs from the population is known as sampling error. So, say that you ran an experiment testing the effects of sugar consumption on short-term memory. You randomly assigned your 50 subject to either a control group that was given a sugar. Let me see, I will send you another PG. Given sugar-free lollipop or to the experimental group that was given a seemingly identical lollipop that contained sugar. You then tested the participants' ability to recall 15 one-syllable nouns. If the experimental group remembered an average of 7 words, and the control group remembered an average of 6.9 words, would you be comfortable concluding that sugar does. In fact, enhance short-term memory. Your gut reaction is probably to say that the 0.1 difference in the example is too small to allow us to draw such a conclusion. Then, what if the experimental group consisted of just one person who recalled all 15 words, while the control group contained one person who remembered only 5 words? You would probably be similarly reluctant to draw any conclusions, even given this enormous difference in the number of words recalled due to the tiny sample size. In both cases, you'd be correct to be skeptical, because the differences between the groups are likely due to sampling error and chance. The purpose of inferential statistics is to help psychologists decide when their findings can be applied to the larger populations. So, many different inferential statistical tests exist, such as t-test, chi-square test, and ANOVAs. They all take into both the magnitude of the difference found and the size of the sample. However, what is most important for you to know is that all these tests yield a p-value. Actually, these are really difficult terminology, so there's also another subject about these statistics. Now I am just still studying about more about ANOVA and like these statistics. And the smaller the p-value, the more significant the result. Scientists have decided that a p-value of 0.05 is a cutoff for statistically significant result. A p-value of 0.05 means that a 5% chance exists that the result occurred by chance. A p-value can never equal 0 because we can never be 100% certain that result did not happen due to chance. As a result, scientists often try to replicate their result, thus gathering more evidence that their initial findings were not due to chance. A p-value can also be computed per any correlation coefficient. The stronger the correlation and the larger the sample, the more likely the relationship will be statistically significant. So maybe today's lecture is a little bit complicated, so for you to understand exactly. So do you have any question about today's lecture?
In this case, nothing so far. But if you like, the inferential statistics is more different and difficult than the descriptive one.
Okay, so let's call it a day. Time is up. So let's continue
Yeah.
tomorrow, APA Oscar guideline. Okay?
Okay, okay, sure.
Okay. Okay, enjoy your day and see you tomorrow. Bye bye.
Goodbye. By the way, what time will be starting the class tomorrow?
Tomorrow, what about having a class at 7 p.m.? I'm sorry.
7 p.m.
Yeah, 7 p.m. Okay.
Yeah, it's okay.
Okay.
7 p.m.
Okay, then see
Yes.
you tomorrow. Okay.
Okay, thank you so much for today and have a great day ahead.
Okay.
Thank you.
Bye.
Bye.